Okay, so these calcium ions will then stimulate these presynaptic vesicles to release that transmitter substance, which is acetylcholine in this case, and they will travel down the intermuscular junction and they will attach to receptors on the sarcolemma, and then this will stimulate sodium ion channels to open, so sodium ions are going to flood in. This is going to create the muscle cell to depolarize. Then once it depolarizes, it creates an action potential. The action potential will then travel down the sarcolemma into the T-tubules, where it will then be close by the sarcoplasmic reticulum, which will then stimulate the sarcoplasmic reticulum to release those calcium ions through that calcium voltage gated ion channel, and then it will be released into sarcoplasm, where the sarcoplasm will then be full of these calcium ions, and then these calcium ions are then going to bind to troponin molecules on that actin filament, and then this will cause conformational changes, or to change its shape, and then troponin molecules and tropomyosin are going to move away, exposing that binding site to those myosin heads. Those myosin heads are then going to attach to that troponin molecule, and then from there it's basically going to hydrolyze ATP, because ATP is going to come over, and because these myosin heads are known as the ATPase, which are going to do this job, and then basically when it creates a product, which is ADP and an organic phosphate, and it gets released, that's when it's going to create that power stroke, which is going to release that actin filament, and then it's going to grab onto it further along, and it's going to pull it towards the M line and towards the center, and this is how your muscles contract.